Hey guys, my name is David Saucier. I'm a research engineer here at CAVS. I work in our Human Factors and Athlete Engineering department, and we'll go check out the lab. Follow me. I'm from Slidell, Louisiana originally, and I got both my bachelor's and my master's here at MSU in computer engineering. And I kind of discovered my passion by accident, basically talking to professors saying, hey, I'd like to do some research. Is there any work that I can do? And there's this project starting, which is what we now call athlete engineering. But at the time, we were just kind of trying out some sensors, trying out some wearables and different things. And I just fell in love with it and stuck around since then. So full-time as a research engineer, I've worked here about 1.5 years, but before that I've also done some undergraduate and graduate research for a couple of years as well. So we do mostly validation of wearable technologies. We also work with our athletic teams with the technologies that they use. So they collect a lot of different types of data to assess their athlete performance, and sometimes it can be almost so much that it's hard to break down what are the important things to look at. So we help them with generating reports and generating the important data to focus on. My favorite part would be just the interdisciplinary aspect of it. So I can talk to a kinesiologist, an electrical engineer, computer engineer, strength coach, fashion designer, all in the same day, and just it can all be on the same project just from a different perspective. So it's humbling and also really cool just to continually be learning from all these different perspectives and backgrounds, mostly focused on human performance and wearables. My specific research interest would be third-party wearable validation. So a lot of these companies are on the cutting edge making these products. You need somebody to validate them and show, what's their efficacy, how accurate they are. So we'd like to be that third party that companies come to validate their product. How can we design an experiment that really shows how this is applicable and measures things accurately? So currently we've got a few projects going on. One would be with our softball coach, Coach Johnson. So he's wanting to do a pitching study where we look at force plate data, motion capture data of their pitchers to look at, what's their max force output, how are the angles of their different parts of their body, of their arms and their legs, how is that affecting their pitch, things like that. Another project we have is working with a company called Strive. So they created these compression shorts that look at your muscle data and your movement data. So we've got this whole season of data from a basketball team. So we're trying to figure out how can we break that out, analyze it, and provide a summary of their athlete's performance over that time. And then the last thing is we also have our smart sock prototype that we've developed, and we're looking to validate that for pressure sensing. So really the main goal is getting enough interest for a lot of companies to reach out to us and let us test out their product and validate it. I've also recently developed an interest in disc golf, so I'd love to do my own study here and get our local MSU team out and try to validate using motion capture and force plates, because it's still a pretty emerging sport and nobody's really done very in-depth studies on it, so I think that'd be pretty fun. So this is an older version of our prototype that we've created. We kind of just abbreviate it as a smart sock. But basically the purpose of it is really what's happening at the foot and ankle can tell you most other things about the human body, and so we've looked into how can we assess the joint angles of the foot and also the pressure under the foot to tell how you walk, your overall performance in a game. Maybe you favor your right leg over your left leg. Is that an issue or not? Could the way you walk be an indicator of a potential injury? So can we kind of track that and detect that before it happens? So the way this works is we use a sensor called a dielectric elastomer sensor. So that's a fancy term basically for the substrate that when you stretch it or when you can compress it, so this is a pressure sensor here, basically doing those things to it will change its output. And so what we've done in the lab is we've taken the data from here, compared it to our motion capture, and tried to make a model to show, okay, I'm at a neutral position, I'm at 120 degrees, things like that. And then maybe I'm favoring the forefoot over the hindfoot. And a lot of those variables can tell us many things about people's health, the way they walk, their overall performance. Really, we ultimately want to commercialize this product, so we would like to use it for, say, healthcare. Can you track a patient outside the hospital and use that as a way to track their progress and recovery for rehab? We also would like to apply it to athletics, so can we monitor our athletes and also inform the coaches more about what's happening at the foot and ankle? Could they be at risk of rolling their ankle or some kind of injury like that? Well, the biggest challenge with this is because these sensors are pretty new, you kind of have to be flexible in looking at what companies are out there. Some company sensors may be good, some may not, so a lot of our time is spent researching these sensors, figuring out which ones are the best ones to use, and then how can we apply it ourselves. I would say what sets us apart is just the culture we've established, especially within athlete engineering. We just have an open communication, everybody's willing to work with each other. Everyone stays pretty humble, knowing that I may have this certain research area that I have expertise in, but not in kinesiology. So I'll reach out to kinesiologists, work with them, and just that open communication and collaboration, I think, makes for some really unique research for Mississippi State.